the video, where you'll be getting to know about how to work with analog inputs using a potentiometer and LDR, which is light dependent resistor. So let's move on with the topics. What are analog inputs? Analog inputs are signals that vary continuously over a range, representing real-world quantities like light, temperature, or position. These are unlike digital inputs, where digital inputs only have two values, which is high or low states. Analog inputs provide much richer or a nuanced set of data to analyze quantities. These inputs allow electronic systems like microcontrollers or sensors to interpret real world information more accurately, making them integral for applications that require gradual adjustments and detailed monitoring. This picture is an example of an analog input where A in and A ground represents the analog values which will be transmitted to the transmitter. Potentiometer. So a potentiometer is defined as a variable resistor that adjusts its voltage in a circuit. It's a manual control device where the user can actually change the resistor value according to the needs. So the common uses of potentiometer are dimming LED brightness. It's used to control volume in audio circuits. It's used in user inputs for electronic projects. The given figure is a potentiometer in real life. So reading analog values with Arduino. Arduino is helps in simulating IoT projects. It's a microcontroller. So reading input values through Arduino can be explained through this. So Arduino reads analog signals using its analog to digital converter. It's called ADC converter, which has around 6 pins, which is A0 to A5. Analog values are converted to digital values, typically which range from 0 to 1023. For example, you can use a potentiometer to control the brightness of an LED. So Arduino reads the changing voltage and adjusts the output accordingly. LDR, which is light dependent resistor. So the basics of LDR is covered in this slide. An LDR or a photoresistor varies its resistance based on the intensity of the incoming light. So how much ever light falls on it, it varies its resistance based on it. In bright light, resistance decreases. In the sense with more light, the resistance decreases. So it's inversely proportional. In dim light, the resistance increases. Obviously vice versa. So the common uses of LDR are automatic street lights, light sensitive alarms, ambient light detection. The given picture, this is a LDR. So this is an example of a LDR and a potentiometer circuit which reads the analog values. These are the analog pins, like it is from A0 to A5. This is a potentiometer. This is a potentiometer, and this is a photoresistor or an LDR. I've connected it accordingly, and now I'm going to simulate it. Before simulating, I'll just show you the code. I've connected the potentiometer's pin to A0, that is analog pin 1, LDR's pin to A1, and then I've started the serial communication with 9600 baud rate, and I'll read the analog value and give it as an output. So let me just check in the serial monitor. So you can actually vary the voltage that you're giving. See, the voltage varies. You can clearly see the voltage varies depending on it, and the brightness of the light decreases or increases accordingly. So from the given video, the summary or the key takeaways are: analog inputs enable responsive interactive electronics by reading variable real-world signals. So, potentiometers and LDRs are foundational sensors for learning analog electronics and automation. And using simulation platforms like Tinkercad and Walkwe offer a risk free way to experiment with these components before moving to physical hardware. Thank you for your attention. Please do like, share, and subscribe to our channel. Thank you.